Welcome everyone to our career development web series sponsored by the Diversity in Life Science Programs portfolio. And today we have Dr. Nora Savage from the National Science Foundation, who will talk about the role of nanotech in medical technologies. And we have two of our Keystone Fellows with us. Two others may be joining. We have Leslie Ann Caromile from UConn Health Center for Vascular Biology, and we have Marcus Jones from Human Longevity in San Diego. Sorry about that, Marcus. I did a mental burp. And we may be joined later by Amal Kulkarni from Howard and Tracy Locklear from Duke University.
Okay.
So we're going to start first with Nora, Dr. Savage, introducing herself, talking a little bit about her career path from postdoc to faculty to working at the National Science Foundation as a scientist, and a little bit about her actual science, and then the importance of finding a mentor and being a good mentor to trainees under her. So let's begin. So Nora, you take it away.
Thanks, Irene. Okay, as Irene said, my name is Nora Savage. I am originally from Boston, and I went to undergrad at Prairie View A&M and then to graduate school in Wisconsin. I did my postdoc at Howard, where I met Irene. At the graduate school, I was working with the dean of the graduate school on specific initiatives that he was working on, and also trying to do some research there in the civil and environmental engineering department there. Because I received my doctorate in 2000 of August, and I started at Howard in August of 2000. In January of 2001, I actually received notification from the Environmental Protection Agency that I had received two jobs. I had been given two jobs, or I had been offered two jobs, I should say. That's the technical vernacular. And one was with the Office of Research and Development within the EPA, and the other one was with the Office of Pesticides. So if you know anything about EPA, it's a regulatory agency, but it also has an extramural research grant program. And so the Office of Research and Development is more of the science-based piece for the agency, and the regulatory arms of the agency, both pesticide, they handle FIFRA, TSCA. If you need me to go through those acronyms, I'll do it later. And Office of OAR, the air regulations, the water regulations, they are more of the sort of machine grinding part of the agency that really just focuses on regulations. So I took the ORD position because I was more interested in the science piece of that. My thesis work was in PM 2.5, particulate matter 2.5 microns and smaller, which I did at Wisconsin. And so as soon as I got to EPA, I got actually involved in nanotechnology, in environmental nanotechnology. And in January, from probably January to, because I had a year appointment at Howard, to the August, I was split. I had 30 hours a week at EPA and 20 at Howard, because I had to keep that 1 year appointment at Howard, and EPA required me to work at least 30 hours to keep that job. So I was crazy, that 1 6-month, 8-month period. Anyway, so to get into, I really want to talk about nanotechnology. So nanotechnology, the piece that I was involved in is environmental, but it actually has a lot of medical aspects to it, which involve, one is really cool drug delivery. So you can now have less invasive, more targeted drug therapies from nanomaterials than you could using chemo or radiation, and you don't have the adverse side effects. And so you can really target the tumor, only hit those cells, and really not affect healthy cells. And so nano has done a lot in terms of health from that perspective and the cancer therapy. It also has worked in terms of imaging, not just cancer, but other diseases. So there's ways that you can make these materials highly fluoresce, put them in the body, and then the doctors can see much more accurately and sort of more finely where the disease is, where the disease tissue is, so they can, if they have to do the invasive surgery, they can operate with much better accuracy. And so nano works in that way. Let me just give a brief overview of nanomaterials before I go into the last piece, which is the mentoring. Nano, as you know, is the U.S. definition, and by U.S. I mean the National Nanotechnology Initiative. And if you're interested in more information here, you can just go to nano.gov. You can find out all about the federal activities in nano. It's really 100 microns, or 100 nanometers or smaller, nanometer being 10 to the minus 9, of course. That's because at that scale, materials take on different properties. So it might have a different optical property, a different color, different electronic property, a different, even a different sort of chemical property. For example, gold at certain nanometer scale is not only not yellow, it's either red or blue, but it melts at different temperatures. And so you can get some of these novel properties that, and by novel we don't mean that we have not seen these properties before. Of course, we've seen the color red and blue, but you don't see it with that material. So that's what nano technology within the NNI means, is that you've got these novel properties for this material that at the bulk scale, you don't see that property. And so we're trying to exploit those properties for the betterment of humans' quality of life, basically. Mentoring, I really enjoy. Mentoring is really very key and important. I've sought mentors a lot. I sought them. I was at EPA 15 years, so I've only been at NSF for the past 2 years now, going into 3. And at both agencies, I was a program director, or I managed a portfolio of grants. At EPA, it involved nano grants. It involved some small business innovation research. It involved some air particulate matter, air quality grants, and I did some water. I've done some water books too. So in terms of trying to find a mentor is someone who can, one, provide you with advice. So you want to get someone that's within your field, but I think it's also key to look for someone who's outside of your field to give you a different perspective, so that you don't, maybe that even though they're not in your field, by field I mean your particular area of expertise or even your career path, they can offer you options of getting to a certain point. They may have anecdotal experience or others that will be useful. So you want to get someone within your field, of course, because that's the career trajectory you're on, but you also should look outside. And so I've got mentors from, for example, social science. I tell people I'm an engineer by education, but I'm a philosopher by heart, because I took a lot of philosophy and writing classes when I was at Madison. I took law as well. And I'm really interested in the social sciences and how that intertwines and interacts with science, physical science, because you really, we try to divorce them. We try to say that art is separate, and art has to be separate, and social science has to be separate from the real science. And I think that's a false dichotomy. We really need as a society to try to merge those two together in students, because it makes you much more holistic. It makes your approaches to environmental protection or medicine even more holistic. I've had medical doctors who have not, who just weren't really good, and the ones who really sat down and asked me about my personal behavior, what I do, those I felt were more in tune with my health and actually had better, were better doctors. Served me better than the others, in my opinion, than the sort of run-of-the-mill, in and out, kind of traditional doctors. But anyway, so I really think mentors are important. So again, I have someone from social science. I have folks that I looked within EPA. I didn't really find anyone within EPA to be a mentor while I was there. So I kind of sort of blazed my own path there, which has its pluses and minuses. And at NSF, I do have a mentor. He's a program director. He is a permanent person because I'm permanent at NSF. I don't know if you know about NSF, but NSF is probably maybe 50 to 60 to 70% the positions of rotators. And so as an academician, if those of you who are in academia, you may want to consider that later on in your career. You can do a stint for 1 to 2 to 4 years at NSF as a program director. You get to see the research support side of what you're doing and the science of what you're doing, and then you go back to your home institution. NSF, pays pretty well to do this. They allow you to keep touch with your graduate students and to go back and forth to your institution to, get caught up with your students, continue your research, etc. So a lot of the people there are rotators. I am permanent. There's several other people in my division which are permanent, and so I selected someone who's permanent to work with me on that. And then I also joined, NSF has what's called a mentor program, and I signed up both as a mentor and as a mentee, because I felt as a mentor, even though I've only been there 2 years, I might be able to provide some information. And as a mentee, I wanted to get some more feedback from people who had been there many, many more years and who could provide me with some useful tips and career guidance information. So that's it. And now we can, I guess, open up for questions. I don't want to take up too much time.
No, that was great. Thanks, Nora. So questions. I know you have questions.
Okay, I'll ask one. So I was thinking about the difference between a mentor and an advocate. And do you think they're the same, or do you think they're like completely different, or can they be the same?
They could be the same, but an advocate is someone who's going to champion you through, say, if you encounter barriers in your career.
Right.
And a mentor is going to provide guidance. A mentor may not want to do that advocacy. So it depends on the person that you select or you identify, I think. And sometimes a mentor is not in a position, right, to be that advocate because they either don't work directly in your office group or your division, and so they really can't. And to step outside of their division to do that might actually be worse for you in the long run, because then someone else may take offense. Why is this person doing this? So if you strategically position it, you might be able to get one and the same.
Right.
Is it wise to do that? I don't see a downside. I don't know. I mean, it could be useful to do that, but just make sure that they're in a position where they're advocating for you will not, one, negatively reflect on you or on them either.
Good advice. Any last wise thoughts for the fellows?
Just always ask questions. I mean, don't be afraid that, sometimes you may think a question is dumb. If you have a question that you didn't want to ask here on the video thing, you want to send me an email. Irene has my contact info. I generally respond to emails immediately, at least within a day or two. When I get busy, sometimes I get a little behind, but, send an email if you have a question. Just always ask the question, because it's better to ask than to say, well, that might seem stupid or someone may take offense. There are people who are really thin-skinned and take offense and things like that. My motto is, I can't, they're going to be hurt throughout life. I can't stop that. So I try to ask questions. You ask it in a nice way, but you ask the question so that you get the information that you need. Mm-hmm.
Well, thank you. Thank you very much, Nora. Thank you for joining the call, the Hangout, Marcus and Leslie. And like I said, this is just the beginning. We're going to do more of these. And National Science Foundation, because they have a commitment to science education and research. So this was perfect. So thanks again, and I think we'll stop here. And as Nora said, I have her contact information. If you have any follow-up questions, like she said, there are no stupid questions. And she is very thick-skinned. I've known Nora for years. So definitely feel free
Exactly.
to share your questions, and I'll be happy to pass them on to her. Okay.
And then please pass that along to the other two fellows too, Irene.
I'll pass it on to the whole group. Yeah, we're going to share this with everyone.
Okay.
Okay. All right. Thanks, Nora.
You're welcome.